Hello everyone, welcome back to channel. So today's problem that we're gonna solve. So this problem looks very hard, and this problem has also been part of multiple interviews. So with all the past problems that we saw, if you are used to the pattern as well as the matching of all those problems, so you should be able to at least think about a certain logic to solve this problem. So in this problem, we have to count the subarrays with exactly k distinct integers. So you would be given a integer array which is of like numbers, and you would have a integer k that will define the distinct integers that you have to find, and you have to return the subarrays with exactly k distinct integers. So why this problem is powerful? Because in the previous we saw the sliding window, somewhere we saw the frequency technique, hash map, and the counting trick. So this problem combines all of them together. So how we are transforming this problem is because we are breaking it into something much easier. As you know, we need to count subarrays with exactly k distinct integers. We can also do some brute force, like we can check all subarrays one by one, and that will be little slow. And the complexity will also go around O(n)2. So instead of solving exactly k directly, what we will do is, to get it, we will find the AtMost k, and then we will subtract AtMost k minus 1. So what does exactly AtMost k means? So we use sliding window and a frequency map. We expand the window, and if distinct elements exceed k, we shrink. So for example, you have 1, 2, 3 as an array. You have k equal to 2. So in a subarray 1 and 2, if you have, that means your two distinct element in a subarray is done. That criteria is met. At each step, we count how many subarrays end at this index. Okay, and then we do some. We found the k minus 1 also the similar way, and we subtract to see what exactly k we have. So if you try to do it by the brute way, you have to check for each array how the things are happening. Subarray you have to count, and then that will give you a very bigger complexity. But you break it into two small problems, and that will help you to combine the sliding window, hash map, counting trick, and also the complexity will reduce. Now let's go to the solution. So here we have a function subarray, okay, which takes a number and number k, and it calls a function again with AtMost k, okay, and we are creating one function which is called like this k and k minus 1, okay, and we're subtracting both of them. Here we have taken two pointers. Left pointer, we have taken the count, and we have taken the frequency map. If you remember, in previous problems also, we have taken this frequency map. So now we are starting a for loop. This is your main loop, which does all the tricks. So we start by the right. You know the sliding window technique. You start, move to right, and shrink from the left. So if the right is less than numbers of length, we do right plus plus. And so we create a constant number where each number from the right index we are adding. Okay. Frequency map, in the frequency map, for that number we are telling how many times that number has come or not. Right? This is the same technique you have seen in previous also. If frequency map number is equal to 1, then we are decreasing. So it means new distinct element we have to find. So this console output I will show in detail when the output runs. Now if this is invalid, if k is less than 0, for example, if you are doing something like this, then in that point of time, we have to shrink, right? So we have to shrink from the left side, and then because right side you are expanding, then we start shrinking from the left side, and that's how we try to find whether which numbers we have to kick out of window or at what point we have to stop. Okay, and then after a certain point we have to count the sub arrays ending at right. Sliding window comes into picture, always ending at right, we have to check. So we take the both pointers and add 1 to them. Then after that we are returning our count. So this method we have written. So we are doing AtMost k if you have 2, AtMost with 2, AtMost with 1. How many we are getting, and we are subtracting them and getting the result. How this exactly is working out, you will see here. For example, this is what it is. You have an array 1 2 1 2 3, something like this. If it's part of 2, this is distinct array 1 2, and if you move here, k is greater than so only 2 subarrays. This is one distinct thing for you, and 3 and 1 will be one distinct thing for you. But let's see one by one how it goes. So initially right is 0, number 1 and k is also 1. Okay, count added, total 1 you have. Then number we increase, number is 2 now, total 3 you have. Then again number 1 came. Okay, so expanded, so now again we expanded, right? Number is 1, k is 0 here because negative has happened. Okay, so count is 3 and your total is 6. How you are doing is you are adding this 3 plus 3 is equal to 6 here. Okay, then again you are doing 4 and 6 plus 4, 10 is your count. Again you are expanding to right, but your k has become negative now. So now you have to start shrinking. And then once you have to start shrinking, so 4 you got shrink left equal to 0, removed 1, removed 2, your total became 13. Count added 3, 3 was added, right? Where is it? Yeah. And then your count again, it became 13. So with the max you had 13, okay, and with AtMost 1 you had 6. So that's how your final answer, it became 13 minus 6 is equal to 7. So now you would be thinking like why this answer is like that, because as soon as you reached the shrinking part, right, the main thing that you have to understand is this part. Once you reached, this is the frame which has start the shrinking thing. Okay, because here 2 is where this distinct is getting removed. This is not distinct. So in the end, when you remove the frame, 1 2 3 is there for you, and that is the distinct one. So you get the sub arrays with exactly 2 distinct numbers here. Okay. So the most of the thing that I want to tell you in this is we are not counting. So we do not count exactly k directly. We eliminate what we do not need here. So that is why the sliding window where we remove from the left as well as addition to the right we are doing here. So this is the problem which is related to where we have to find the sub arrays with exactly key distinct integers. And this is one of the most asked problem. So you will not be directly asked a problem like this, that you have to count subarray, something like this. What you would be asked is a certain question where something like up and down bike is going over the hill and you have to count certain distance, or something like this. Then you have to understand which pattern you have to put into coding into that, so that the problem you solve, it's always not about how exactly you solve or do you get the exact output of this 13 minus 6 is equal to 7. What matters is the pattern that you are putting and the complexity of that pattern, how less that is. So yeah, now let's meet again in the next problem, where again the DSA related to more patterns I'll be explaining. And thank you. If you like the video, subscribe the channel.